We have skeletons starting with the most simple, advancing to the most complex, which ends with the adult skeleton body. Which the human body is the most complex machine in the universe. And that
last limbs is floating on the top of that corner.
Thank you. Maybe I'll find something. Rick, did you find something in this other one here? Because I can't.
I bet he will be. He's really good at people.
Which are single-celled organisms. And they move, and they are really cool to look at under microscopes. And we're in the microbiology class, and we're trying to find all these little critters. And we're not really that good at it yet, but it's okay, because we're learning. Hi, how are you? Did you want to look at some stuff? We've got these, let's see, what do we got over here? Well, right here we're looking at a hydra plant. We're looking at a plant. Is there something in there? That one's not really that cool to look at. But what it is,
A hydrant, like a water plant?
it's like actually a little protozoa. It's a freshwater protozoa. And these things are alive on these plants. And in ponds, they're alive. And what they do, they have these little tentacles. And they like go flip over and over and over. That's how they move. And it's really cool. You can't really see it on here, but they just look like little worms. But if you were to look in here, it blows it up and makes it
Look up in there, Anna.
Are you able to look in there? Can you see? And the really cool thing about these little things here is if you cut them in half and you cut them in three times, they actually grow. And they just kind of grow and make themselves over and over again. So they're called the eternal animal. And it's amazing because they can regenerate, they can regrow, they can get bigger. Just like, okay, let's look at some really pretty stuff. There are some really cool little, you find these at the bottom of the sea, all these little, I don't know, what do you call these? These little coral plants? Did you want to look at that under there? Can you look through the lens? And if it's too blurry, you can kind of turn this knobby right here. Can you see this knobby? You can turn that up or down to make it clear. That's what you have to do.
And that's what they're observing right now. It's just
So you can see it really good.
Can you see everything in all those little
You
holes?
can see all the little sand. Isn't that so cool? I've got another one to show you. Look at this crystal.
Did you?
It looks like ice.
I didn't want to butt in
Like
front of
ice
you.
is snow day. Yeah, it sparkles and shimmers. Did you want to go here?
Yes.
I know, but it's cool looking.
Okay. So we're demonstrating plants breathing because plants produce oxygen for us, okay? They turn CO2 into oxygen. What we're showing here, we put a dye in here that starts out red. When it's in a neutral solution, it starts out red. When it's in an acidic solution, it turns yellow or kind of an orangish color. Okay, we breathed into here, put CO2, then we sealed it off. These two have been in the light and the dark, so there are controls. So we know that it wasn't just the light affecting
They
the
could have
dye.
moved out of the.
These two have plants. This plant has been in the light. This one has been in the dark.
That one's bigger.
It is a little bit bigger. This one has been photosynthesizing for a week.
What does that mean?
That means that it's respirating, it's breathing, and it's creating food for itself for us. In that process, it turns that CO2 we put in here into oxygen and makes this neutral again. Okay, this one's been in the dark. It can't do photosynthesis without light.
So you have to feed it.
Well, it still has food stores in it, but it hasn't been able to put oxygen back into the solution, so it's still acidic. That's why it's still yellow.
Oh, cool. We want to do that.
This one
Oh, wow.
has been, this test tube was completely full with water at the start of the week. This is all oxygen that this plant has produced. Well, you can move it a little bit. The plant itself is not, but probably some of the stuff in there is.
Cool. How come these are in here?
those are controls. So we wanted to make sure it wasn't just the light that was changing the color of the dye, but actually the acidity.
I'm really clumsy.
It's
I'm
okay.
very clumsy.
That's okay. Now, if you look over here, leaves have openings on the bottom of them. Okay, those are called stoma, and that's how they breathe. Like we breathe through our nose. You can think of this as kind of the nose of the plant where it breathes out, takes air in. Those stoma will open and close. They've got cells on either side that do that. Those cells that you're seeing in there are the bright green spots. You can see them really well on this purple background because this is a very purple leaf. On very green leaves, you don't see it quite as well. Cool. Yes. And we've also got, if you want to see the actual cells inside of a leaf, we have some cells that you can look at.
Can I see that?
Actual cells of that leaf. Now leaves have cell walls, so it's not like ours where it's just like a little kind of. There's actually a hardened wall. That's what you see in like stems and leaves that makes them more rigid. That's cellulose. If you've ever heard of it, that's cellulose. That's what that is. So you'll see the cell walls. You're going to see little green discs or dots inside of those cells. Those are chloroplasts. When you see the green part of the leaf, you're looking at chlorophyll. The chloroplasts contain the chlorophyll.
Okay. Well, the main purpose of our experiment was to keep the rocket from doing this and completely destroying. We made the propellers out of cardboard first, and after trial and error, we decided that we needed them to be water resistant, and so we decided to wrap them in duct tape, but it added a lot of weight, so it resulted in less maximum height. And it turns out from our graphs that the longer the propeller length, the slower average speed, which resulted in less impact damage. And that's about it. Kept all of our trial and error and stuff in this engineering notebook and kind of just wrote it as we went. Show all of our fails and our successes.
Alright, this material is put into diapers to absorb the water, or it can be used for potting soil, or the detergent packs, or you can put it in your hair, or you can make artificial snow out of it, and it will absorb all the water, keep it in there, and you can also put it in the ice packs for like lunches and stuff. And this is what it looks like with 9 cups of water. And then this is the actual stuff out of the bottle. And this is what it looks like, the diaper. That's all I got.
That's good enough.
That's all I got. And now someone else is coming out.
If you come back in about 5 minutes, I can demonstrate.
Come back in 5 minutes.
This is still trying to see. I'm trying to get it to do without crystals.
So this is my catapult. I was basically just trying to see what I could use to build a catapult out of what you would normally find in a garage, such as like wood, washers, ties, string, a little metal wad here. And this is what I came up with. Right here, okay, this is how you bring this down and use this piece to set over it. And this string is on there, you can use it optional, like you can pull down on the string if you put it on here to launch it, but I prefer to just push it to launch it. It works either way. These rubber bands are what is used to actually launch it, to pull the board on it, and based on what you're launching, you might want to switch out to like stronger rubber bands or stronger, maybe even a spring. Springs work on this too. I had a spring on here, but I decided to change it for display. And that's my catapult.
All right. Thank you.
So the torsion in here
it's basically my trigger. You know, it's kind of like my trigger. It pulls it. It's like it's power. You know, potential energy is stored in there. While I make this in here. So it's like it has a lot of potential energy, and I use this bungee cord as its help. Because when I was test firing it didn't go as far as me and my father expected. Alright, so as any regular catapult, I have an eye, or let's see, a pin, so I don't get hit while pulling this away. So I pull this back as far as I can. Of course, I have this as far as I need to go. So I add this, and this pin is also a locking pin, so whenever I need it to stay in a position, I will. My ball.
Just gonna stick figure of you.
This is basically my catapult. It's very heavy. It took us forever to get down.
Alright.
It's like Diablo. School colors are red and, black and red, but we should decide to make red and black.
Thank you. I am Haley Richardson from Akron High. I'm a senior, or sophomore at Akron High. This is Michaela Fall. She's a 8th grader at Akron Middle School. And I'm Jade, and I'm an 8th grader too. Okay, this is pretty much we pretty much did this to see if maybe there was a rhyme or reason to why some eggs hatched and some didn't. So we got together and thought maybe the egg size and breed will affect it. And in the beginning, we thought maybe the bigger eggs or smaller eggs will hatch first and most. And we did some experiments and we studied them. And we found in the end that the bigger eggs hatch first. What we would put the chickens in the incubator, fat end on bottom. That way the air pocket will grow on top where the egg will form, the head will form. And we put 60 milliliters of water in the first tunnel only on the incubator until about the last 2 days. The last 2 days we took them out of the turner and we put 60 milliliters of water in the first 2 tunnels afterwards until they hatched. Due to the fact that when a mother hen lays on them, she will not get off the last 2 days, which will raise the humidity up. And we kept the humidity up between 40 and 60% while the temperature stayed 100 the whole time.
When you handle the egg, you want to put it like this so the air pocket will not, it will let the air pass. Because if you turn it like this, the body will block it.
So to speak, the pointed end has to be where you put the light, so the body won't stop the light from showing and you can see what classification it will be. There are 3 classifications. A yolker, it is an egg, it will be clear when you look at it, like that on the inside. We don't need that. But we put the flashlight under it on the pointed end so we can see through the air pocket, and you'll see no dark shades, no blood cells, anything. And that is where a chicken does not grow at all. A quitter, you will flashlight it and you will see a dark shape at the fat end. And where the air pocket is, you will see where blood vessels came together and created a ring around it. That is where in the first 7 days the chicken started growing but did not continue. And a winner, you will see the dark object at the fat end, and the ring, instead of being a ring, you will see here like blood cells spread out, healthy ones, like hair follicles, so to speak. And it is when the chicks will hatch.
So I made a catapult. It's made out of a rat trap, a spoon, and now the springs on the rat trap are the fulcrum that we use to launch the spoon, or to launch the beanbag, and the spoon will help hold the beanbag, and it's taped to the arm of the rat trap, so that way it can stay attached to the rat trap.
Thank you.
Big pot of water and boil it, and just put the pot in there and boil it until it gets a nice color. I guess we didn't
Actually, a friend of mine did a lot of different classes to learn how to dye fabrics naturally, and in order to get really vibrant reds, she ended up actually using a lot of bugs of a certain kind.
Yeah.
It was really interesting to see her do that.
Yeah. Yeah, we actually found that on the internet. It's done that for a while.
We're spoiled with all the red that we see these days.
Yeah.
Like without the artificial dyes.
Okay, so we were doing some research on synthetic dye, and it's really, really bad for you. It actually causes hyperactivity in some children, and it increases your risk of cancer. So what we did is over here we have synthetic versus natural, and we made the natural with raspberries, blueberries, spinach, carrots, and red cabbage water. And the candle is always a little bit, but it's still a really nice color. And the thing with the red cabbage is it's neutral. So if you add acid, it'll turn pink, and if you add base, it'll turn blue. So we got that's just plain cabbage water, and it's just purple. And if you add base, which we use baking soda, it'll turn blue. Yeah, and that's how we got our dye for that. And if you add acid, which we use vinegar, it'll return back to its original color.
Very good.
And synthetic food dye is in everything that's processed. I mean, like, there are a few things that don't have it, but really a lot of it. Like, some things it's kind of obvious, but even in stuff like marshmallows, like there's food dye in here, and vanilla pudding, it has yellow in it.
Right.
Doritos, M&Ms, and strawberry jello. And the one that's food dye that's really, really good for you is red 40. It's just really powerful.
You go to demonstrate first, stay out of the way.
So what's your recommendation as we go shopping then for groceries?
For just processed foods? I don't know. We try to stay away from as much processed as possible. Sometimes we make our own macaroni and cheese out of organic cheese powder and organic noodles. And that helps a lot. We buy like this kind of stuff, but it's natural.
Right.
So yeah, that's just at the end of each ingredient list. Usually it'll list if there's any color, so just check that. And
So I'm going to start reading labels a lot more closely. Okay. Very good work. Thank you.
Okay.
So this is chromatography, and it's the process of separating components from different chemical mixtures. So for this I decided to use Crazy Art markers, washable markers, and Sargent Art washable paint. So for the paint, I used black, and for the crazy art, I also used black. So it showed that the green and the pink were most polar because they rose with the water the most. And the crazy art markers were also, the green and blue were most polar because they rose the highest. Pink is also polar. And the crazy art markers had no non-polar components, but the Sargent art had blue as the main non-polar component. I figure that's because of the heaviness of the paint rather than the crazy art, because it's a lot heavier than the lightness of the crazy art. So after I did that, I decided to look at some more colors and what they were made up of. So I chose gray, purple, orange, and brown, and the gray separated into many different colors, light pink, blue, green, pink, all those colors. And I've had some people try their own colors, pick their own colors, and they came up with really nice results.
Hey, how you doing? Alright. You had good videos taken? So far. Got a real good conversation.
Well, we have a little static electricity display here. Sorry, what's the brand? It's memory time. We can cut this out, right? So if you rub this little rubber balloon against this little sock, what you have happening here is rubber has an affinity for electrons, and so this has a negative static electric field. And you can see over here this little electroscope. As the electrons move into this little piece of metal here, they also transfer into the foil, and they repel each other because there's an excess of the same charge, negative charge electrons. And you can also see here with the generator that we have produces a positive charge, and as it's on, there's a lack of electrons here, so it has a positive charge, and it will draw the negative balloon to it, and now repel it because they evened out, and now this balloon has a positive charge. Did I get a decent shot? Strong. Repel.
Okay, my name is Garrett Murphy, and this is the Murphy's Law Catapult. And if you don't know, Murphy's Law is what can go wrong will go wrong. And I made this thing out of 2x4s, a dowel rod, several golden screws, and some bungee cords, and 2 eye hooks. And what you do is you can pull this thing back, stick this through the eye hook right here into this hole in this 2x4 right here, and whenever you get ready to launch it, pull it, and it'll throw what you got in it. I don't know really what else to describe in it other than that it'll go up to about 12 foot with those 2 bungee cords on it, and I believe 14 with this. And that's it. That's all I got.
You don't have having fun with liquid nitrogen, which is nitrogen is all around us all the time. 78% of it's in the air. Liquid nitrogen is just a compressed version of it, I guess. Vacuum sealed, they get all the heat out, it turns into liquid. As it's stored in here, it's about negative 324 degrees Fahrenheit. It actually boils at negative 323 degrees. It freezes at negative 346 degrees. So basically anything outside of this container is going to make it boil and turn into gas. It's used to freeze food sometimes. It's used to make ice cream. I can literally freeze this. This portion of the watermelon is going to freeze in 20 seconds. It's already at boiling and it's just room temperature in here. Turning back into gas. It won't completely freeze it unless it's submerged, but it'll be pretty frozen when I take it out. Kind of looks cool too. Kind of froze. Still good to eat though. That's liquid nitrogen.
Dries. The frozen form of CO2. CO2 freezes about negative 107 degrees, and since it's so cold when you drop it in water, which is about room temperature, it'll warm the ice up and actually create a fog. Since it's the only way to actually put NO2 in its liquid form is with extreme pressure. This is with nothing that can actually withstand that pressure, but nothing to actually convert it into liquid form. But since the fog is so dense, you can actually just pour it into a jar. And it will just hang out there. You can actually just pour it in. And then you actually get soap on a rag. You rub it over the cup. The bubble will actually fill up with CO2 gas until eventually the bubble will pop and then all the gas will just flow out. Eventually, just flow out of it. That's about it. Alright.
Alright, so what I'm creating here is a video game that's based entirely on chemistry. All the characters, the story progression, the gameplay, it's all based on what you would find in a real life lab experiment, or just in theoretical chemistry. The point of the game is each player has a character on their respective side of the field, and the point is to push your elements to try and defeat that noble gas. So you have to balance offense and defense. I've tried to wrap it up with mainstream video game elements so that it's appealing to today's generation, which is very caught up in video games. But I also hope to create mental triggers to help people remember things about chemistry that they'll need to know for an AP exam. But overall, it's pseudo-educational, and personally, I think that it would be a lot more enjoyable than a lot of the education games that we have these days.
I'll be right back. Well, if you'll notice right down here, we got some copper that's staying and glowing red. The reason that happens is due to copper being a catalyst for the reaction of acetone and the diatomic oxygen in the air being able to readily and easily break down into acetaldehyde, carbon dioxide, and water. Copper acts as a catalyst in this reaction in that all it does is that it never changes, it just lowers the energy required for acetone to break down into aldehyde, carbon dioxide, and water. The effect of this that you get to see and watch is that the copper glows and stays red hot for a really long period of time. This is important in that in industrial applications, you don't have to use such volatile chemicals, intense heat or pressure, and your yield, your products are there's more of them, and they're of a better quality when you use a heterogeneous catalyst. It's similar to the way that a catalytic converter in your car works at breaking down nitrates into nitrogen gas as opposed to nitric acid. Also, the enzymes in your body are some of the world's best known catalysts in that they take complex, stiff molecules like protein and they start breaking them down with proteinase in your mouth, and eventually it gets to your small intestine and there's amino acids which you use to turn into skin and various other organs, since your cells are replenished at a very high rate.
Okay, so in this experiment, we tried a combination of things. We tried buttermilk first off, and we didn't quite get the results we wanted, so we decided to make our own with lemon juice and regular milk. And we also did plain yogurt mixed with water to make it a little bit thinner. And we found that when you mix food coloring in all of these things, they each do something different because of the different fat and protein levels in each one, which is why we have different reactions for each thing.
Okay, so my experiment is the oscillating reaction, and basically what it is the concentration of iodine going from high to low, and you can see a color change from going from yellow to blue, and it goes yellow and then blue and then yellow and then blue, and it keeps doing that over and over.
What antics for?
It's up quite a bit.
It was ice cream.
One, would you win? Brand new car?
Well, what we have here is sodium acetate trihydrate. It is the result of baking soda and vinegar's reaction. And in high enough concentrations, it can be a super cool liquid. Just got some of the sodium crystals already right here. You got it in the frame? Huh? Do you have it in the frame?
Yeah.
Alright. And then just touch it like that.
I built it out of everything I have no find in my garage, like
It's instantly solidified.
I just used toothbrushes, washers. This was
guys, we started a couple of hours ago and now we are here at 1 o'clock. It's the award ceremony time. Okay? Thank you so much for all of you coming here. I'd like to thank you, some of the sponsors that we have before we actually start the award ceremony. So first of all, I would like to thank Maureen Kise and Dr. Hector Costa Magna for sponsoring for the Best Project Award, which is $300 cash prize. Okay. Also, I would like to thank Union Bank of Mina for sponsoring the Most Creative Award, and that was $250. And then I would like to thank Walmart for Honorable Mention Awards, Mina Walmart for Honorable Mention Awards. They're each $50 cash prize, which is Walmart gift card. Okay. I would also like to thank the University of Arkansas Rich Mountain Foundation Board, which provided all other awards, all other category awards, cash prize awards. I would also like to thank Vivek for the refreshments that we had outside, as well as the University of Arkansas Rich Mountain Foundation for the refreshment we had. Okay. With that, I would like to call our esteemed judges that helped a lot. We would be nowhere without them, so we would like to invite our esteemed judge, Dr. Timmerman, Sean Couch, Laura Hussman, it's all right. And then I would like to call all the participants, okay, for the display, for the competition. All of the participants, if you were the presenters, please come up and here. We will award you with the certificates. Andrew, I think he's busy back there. If you would provide me with the yellow envelope, we would. Joyce can do that. Yeah, thank you. Yellow envelope on the table. And we will like to have each one of the participants come forward and receive their certificates. Okay? Joyce, so when Joyce reads the name, please come up here and get the certificate.
This award is for Haley Richardson.
Yay, Haley!
Yay, Haley! Michaela Fall.
Turn this way, please. Thank you.
Christopher Thompson. Shatika Gaimwali. Jacob Azel. Trayla Costa. Nicole Hill. Ivan Obregon. Sanjal Ganwali. Garrett Murphy. Marissa Grafton. Austin Tweedle. Emilio Soto. Ty Gillespie. Mike Smith. Jerusha Tedder. Andrew Ducott. Chance Lyle. Lachey Holder. Ethan Byrne. Sarah Jenkins. Alicia Biggerstaff. Miranda Burke. Beth Aprilberg.
Thank you so much. I know we have some of the certificates left out here because of some technical difficulties. We didn't have those names already, so we will provide those certificates for you who participated here. Okay? Then now is the time for the awards, where we have we have different category awards. I will go from the honorable mention awards. Okay. First of all, community choice honorable mention awards goes to Catapult 1. Will be the title of the league, so you will be the title one, so make sure you have your title with you, right? Okay? The most creative honorable mention, Chem Champions. Best project, honorable mention, Hot Ice. For this award, I would like to invite Jared McCormick. Yay, Jared! The most creative second place award goes to Oscillating Reaction. And the second place for this award, for the best project, second place, I would like to invite Joyce to give this award. And the second place winner for the best project is Black Ink Really Black? Alright, moving on, we have now first place Community Choice Award. To give this award, I would like to invite Mr. Sean Couch. And the award goes to Natural Dye. Choice First Place Award. Congratulations. For this award, I would like to invite Dr. Timmerman. This is Most Creative First Place Award goes to Hatching Eggs.
Yeah. Be excited. No, Mr. Geese.
I will join. the next one, first place in the best project. You have any guesses? Okay. And I would like to invite Laura Husband to give this award. First place, best project, goes to X Impact. Now you all know that these big checks will not be turned into cash in banks. You know that, right? So we will be sending you real checks. That's why we have collected your mailing address, and we will make sure that those addresses are right to send you the checks. If you are a group, however you want to contribute to the award, it's up to you. So now what we would like to do is take a group picture with all award winners, all participants together with our judges and everyone here who wants to take the picture here. But participants and judges, please come over here. All the participants with your certificates, please. Oh, we can't do that. I'm pretty sorry we forgot about these awards that were to be awarded to the first prize winners. Let's get these awards given to, because we had big checks. Money was bigger than these. So.